All right. So that was my time. Welcome to Austin. I know that many of you are already from here. Those of you who are visiting, thanks for traveling in, especially to our speakers. You know, the community here in Austin is awesome. I'm not saying that just because I live here. I think that we have so many great tech companies and so much great history here in Austin around my favorite part of the tech stack, which is like the infrastructure. You know, like how do we make all of these amazing ideas turn into reality in the tech world? Well, it all eventually goes down to like compute and storage and networking. And you know, to me, I love being in Austin and getting to work with so many great tech folks and tech companies. As Lisa Marie said, you know, this is about a year into my CNCF journey, and also been amazing. Been able to go all over the world and talk with so many people in the cloud native community. So many people who are at this kind of like pivot point that we're all at right now, which is sort of going, what does AI mean for me and for my company and for you know, the technology decisions we have to make. And it's been very interesting to me to kind of see how that is impacting the cloud native stack. And so today I want to talk about a little bit about like where I think the most important layer of the AI stack is making the most progress right now, and how that relates to cloud native technologies. Katie gave an amazing overview of the CNCF community, so I'm going to just like speed through the first slides because she already covered this in much more detail than I did. But you know, we're all here in Austin, but we're all part of something that's global and amazing and really, really huge and kind of unparalleled in the technology and open source world, which is this massive community of hundreds of thousands of people, pretty much every country in the world, building together. And you know, open source to me is so special because of that. You know, it's one of the only ways where you can work with someone from every country, every company, every community, and do a thing that's like we all are building it together and then giving it to the world for free. So that's awesome. One of the signs of this is the KubeCon that we just had in Amsterdam was our biggest KubeCon ever. How many of you were in Amsterdam? I know you were. Yeah. Okay, great. So we had 13,500 people there, and you know, we are, as Katie said, we're 10 years into the CNCF, and yet we're still growing, and we're having our biggest events ever, and we now do 5 KubeCons a year. In the next couple of months, we're going to do a KubeCon in India in June, a KubeCon in Japan in July, a KubeCon in China, in Shanghai in September, and then we're coming to Salt Lake City for KubeCon North America in November. So, you know, this, as I said, we're here in Austin, but we're part of something that's truly global, and it's a really special thing, I think, to be able to be part of this community. So, what I have said recently, and I think this is very true, is that as I've like gotten embedded into cloud native, I see the two biggest trends in technology merging, cloud native and AI. They're not separate trends. They're not things that are happening in kind of in a different space. They're actually coming together because cloud native is the underpinning for how compute workloads are deployed, scaled, observed, secured, you know, managed. And obviously, AI is the biggest compute workload that we've ever seen. But what specifically is happening right now? Like, what is driving all of this investment? We just had a lot of the big tech companies do their earnings calls in the last couple of weeks. I don't know if anybody here loves earnings calls. I love earnings calls, you know. And what did they all talk about? Does anybody know like a number that Google, Amazon, Microsoft, they all report on their earnings calls now?
I know stock going up.
Well, stocks are going up, yeah, but they all report about CapEx, right? This is a thing that their data center spend is now a thing that they all have to talk about on their earnings calls. Isn't that like such a nerdy thing to talk about? You know, what they're talking about is like, how many servers are we buying? How much network capacity are we buying? How many megawatts and now gigawatts of data center capacity are we bringing online? That's so cool to me. Because used to, that was like nerdy stuff that nobody wanted to talk about. But what is driving all of that investment, all of that spend? Where is it going? Well, Katie talked a little bit about this as well. But there are really three pillars to AI, and in the open source world, which I care about, open source specifically, training, inference, and agents, we have amazing open source technologies at each of these pillars. On the training side, we have PyTorch, we have a whole layer of data tools to get data cleaned and into a training pipeline. We have Kubeflow in CNCF to help manage all of these things and run that. On the inference side, we take those models, we run them, we answer questions, we make predictions. Agents, we take the models and we connect them into applications and into kind of like our daily life. And we have open source technologies at each of those stacks that are really, really powerful. If we dive a little deeper into each of these though, where a lot of the news cycle has been for years and years now has been around training, right? Who's got a new model coming? What's the new model that's going to drop? Is it Opus 4.7? Is it GPT 5.5? Is it DeepSeek? Is it StepFun? Is it, on and on and on, right? And this is kind of like what people have been obsessed with. But this is a thing that costs a lot of money, takes a lot of hardware, and only a handful of companies can truly do this at the level of the frontier labs. I had this bullet in here about the Colossus data center that xAI has built with hundreds of thousands of GPUs. We'll get to that in a second. What are they doing with it now? Well, they're not doing training. And it's really interesting to me to see how there's a shift that's happening right now where we're moving from this thing that we've kind of figured out, that's mature, that has had a lot of investment, and we're pivoting towards a different kind of workload in AI that is really where all of this investment is going, and that is inference. And inference is something that has started to pick up steam. It was a word that not many people were talking about 6 months ago, and now we hear about it a lot. And it's because inference is where AI moves from the lab to the factory, right? The lab is where you're creating new models. You are doing a lot of very cutting-edge things. It takes a lot of time. Inference is where you are answering questions and making predictions all day, every day. And this is where we see a lot of also like differentiation from just the major frontier labs. So Uber spoke at our KubeCon in Amsterdam, and they talked about how they do AI inside of Uber. And I think that it's a little bit of a snapshot of the future of how all companies are going to be doing AI in the future. So they have hundreds of active AI projects internally. They have this infrastructure that allows people to tap into this AI infrastructure and to build their own models, to build their own agents, and to do it in this way where they're able to kind of accelerate the usage of AI and these intelligent systems across the entire product set. They are like truly, and have been for years now, an AI-first company throughout the product. They have 5,000 models in production. But my favorite stat that they talk about is they do 20,000 training runs a month. Isn't that interesting? What does that mean? It means, on average, each of their models is getting trained 4 times a month. Some of them don't get trained every month. Some of them get trained every few days. Why is that? Well, where does Uber operate? Uber is not trying to build an Opus 4.7 or a ChatGPT 5 that can answer whatever random question you woke up with this morning. They are operating in the real world. And what does the real world look like? The streets of Austin today don't look the same as they did yesterday. And that is a thing that they have to build into all of their AI systems. So they're constantly rebuilding the models for each of their cities to understand, what is happening in Austin, what's happening in Dallas, what's happening in Houston, what's happening in, they're in 600 or 700 cities around the world. So this is, to me, like a really cool glimpse at where I think all companies will be in a few years from now. We're going to kind of get beyond the ChatGPT proof of concept of, wow, AI is really cool and it can help us in so many ways, and we're going to get to the true utility of it. And that's where specialized models, I think, are something that we're starting to hear more and more about. And a specialized model doesn't mean that you are building your own model from scratch necessarily. You might be doing fine-tuning or reinforcement learning on an existing model to make it better at your domain. You might be feeding it your data so that it has knowledge that doesn't exist on the public internet. There are all kinds of ways that you can get into the specialized model kind of world. But ultimately, whenever you're talking about any of these elements to scale it, we need tokens. We need inference. And this is the biggest bottleneck that exists for kind of the Uber model spreading to more and more companies, and for people being able to push AI beyond the chatbot world and into something that touches every aspect of what we all work on. So this is where we get back to inference. And I mentioned moving from training to inference. This is an interesting stat to me. This is from a McKinsey report. This year, 2/3 of AI workloads will be used for inference, and 1/3 will be used for training. 3 years ago, this was completely flipped. 2/3 of AI compute was dedicated to training, and only 1/3 was to inference. So in 3 years, that's changed completely. If you go out just a few more years to 2030, they are projecting that there will be 93 gigawatts of compute online just for inference workloads. This isn't all AI, this is just for inference. And that is more than all compute that exists today. Isn't that wild? So when I like to say that inference is the biggest workload in human history, and now I have a data point to back it up from McKinsey, so cool. But this is for real the biggest investment, the biggest workload, the biggest thing that we've ever put computers to work on. And what's amazing about it is, to me, this is the moment that the cloud native community was kind of built for. We didn't create Kubernetes and Prometheus and OpenTelemetry and Envoy and on and on and on. We didn't create these for inference, but we created them for scalable, observable, distributed systems. And now we have kind of like the perfect workload to come along and take advantage of all of that work that our community has done. So to me, what an incredible time to be in technology and also in the plumbing parts of technology. We get to be building these systems that are going to power the biggest workload in human history, and we get to hear the largest tech companies in the world talking about their spend on this stuff on their earnings calls. Infrastructure is cool again. So what does it mean, though, for our projects and for all of us who are working? We have a really good head start because we built distributed systems and we built a whole stack to run distributed workloads. But there are some differences in these AI systems. And so what I think we need to constantly be thinking about is, where do we make updates to our existing projects, and where do we need to bring in net new projects to solve for this? If you look at Kubernetes, for instance, there's an inference gateway. Katie talked about the AI Conformance program. We're doing things to keep Kubernetes moving forward and being a great tool for running these kinds of workloads. But we also have net new capabilities that we need to add to our stable, our fleet of projects. And one of those is something that we just announced as joining the CNCF sandbox in Amsterdam, which is called LLMD. How many of you have heard of LLMD? Great, okay. That's amazing, because when I asked that question a few months ago, it was not that many hands. But this is a project that takes kind of like the cloud native primitives and builds around it to be really, really good at inference specifically. And it pulls in other open source projects like vLLM, which is part of the PyTorch Foundation. It adds on intelligent routing, KV cache offloads so that you can scale across multiple GPUs. And it's really built for inference in an accelerator native environment using cloud native tools. And to me, it's like, again, a glimpse at the future of where we can go and the kinds of things that we can accomplish in order to meet the moment that we have here. Right now, everybody talks about agents all day long, at least in my life. And agents are cool, and we're going to have a lot of them, and we're going to have some that work, probably. But we can't get there without inference, because ultimately, what are agents doing? Agents are consuming tokens. They're consuming the output of these inference systems. So we want agents. We can't have it without inference. And this is, to me, again, why I think it's so important that we're building these really, really capable infrastructure systems right now. When you look at it, though, we have an agentic AI foundation now within the Linux Foundation network of foundations that is focused on some very key agentic-specific needs. But we still have things like security and networking and routing that are going to need to be visible and connected to the underlying infrastructure. So even when we talk about agentic workloads, sandboxing, security, networking, routing, all these kinds of things, we need to make sure that we're also keeping our eye on that in the CNCF world and in our cloud native projects, so that we can really deliver on the promise of it. And we have a lot of cool sandbox projects that, like I mentioned OpenFGA as just one example, but there are a bunch of examples in the CNCF project pool where we are figuring out how to build this type of infrastructure and how to make it work. We have like this kind of set of principles for cloud native that have been around for many years. Container-based workloads, microservice architecture, all routed over a service mesh. I think that we're going to start to see what the agents need to add on to that. And some of these are going to live within the CNCF. Some of them are going to live elsewhere. But we are at this really cool moment where we are in the middle of all of this, and our projects are in the middle of all of this. And we have a great opportunity to be able to kind of lean into that and push forward with it. So to summarize, we're at this pivot point where I think the world is waking up to the fact that training is really cool, and we've all been obsessed with that, and it's been neat to hear about. But we got to have a lot more inference if we are planning to to actually deploy these models and make use of them at scale. And this is a perfect workload for cloud native and for the principles that we have been building on for a decade. We also have things that we still need to do. And we have such a big head start. Let's not waste it. Let's figure out where those gaps are in our existing projects, where we might need new projects, and go take advantage of this, because I think it's going to be truly the biggest thing that has ever happened in the tech industry. That sounds like hyperbole, but I think this is the moment that we're at, and we're right in the middle of it. So that's a pretty fun spot to be. So thank you all for coming, and I will hand it back over to our MCs.